nutshell.
So tell me a little bit about what you do at Honeywell.
So I am the general manager for a new startup within Honeywell. So it's a very unique position to do a startup inside a multinational. I come from the transportation business where I have 15 years experience on the turbo side. 2 years ago I got a very unique opportunity to lead a business where we're going to take and bring advanced control into the automotive domain.
So advanced control, what does that mean?
So advanced control is really taking advanced scientific control principles that are multiple generations ahead of what's happening today. Most control on an engine today is single input, single output. You've got one sensor, one actuator, and you're trying to control the engine with a whole bunch of these single input, single output controllers that are working in a truly interrelated system. So when one actuator moves, it affects the feedback on many of the sensors. What we're doing is bringing, it's called MPC, so Model Predictive Control. But what it is it's a true multivariable controller that's able to predict what the response will be on all of the sensors after it moves any one of the actuators, and therefore coordinate all of that control to bring a unique set of benefits to the engine manufacturer and the end consumer.
So I saw your press release you put out on this. It says you're bringing fighter jet technology to cars. Do cars really need fighter jet technology, and isn't that just going to make them more expensive?
In this case, it actually makes the cars more affordable. Because what we're doing is we're bringing the technology that's being used to optimize the control of a number of processes, including fighter jets, into the automotive space to allow the OEMs to do three key things. The first is reduce their time to develop. This will improve their time to market and improve their cost of development, which again should ultimately lead to a better commercial proposition for the end consumer. The second thing we do is we help the OEM improve the fuel economy, the emissions, and the ultimate performance of the vehicle. So now the vehicle becomes more cost efficient for the owner of the car. The third thing the technology does is it improves the reliability and reduces the warranty cost of the vehicle, which again will give you a lower total cost of ownership for the vehicle and the OEM manufacturing the vehicle.
How does a control make for lower warranty costs?
It's very interesting. So if you think about on today's engines, you have all of these individual controllers. They're actually fighting with each other because they're interrelated in terms of what they're controlling, but they're only thinking about a single problem statement at a time. So when controller A moves its actuator to try and get its sensor to where it needs it to be, it actually impacts controller B, controller C, controller D, and those controllers now all have to respond and move their actuators accordingly. So you have this dancing or oscillating that's occurring on the engine while each of these actuators is trying to find its happy state. With our advanced control techniques, when there's a change in the desired position for any one of those sensors, all the actuators can be moved simultaneously through a much lower actuator movement to get you to that desired point in a shorter period of time. So we're able to see upwards of 70% reduction in actuator motion over the same drive cycle on the engine.
And you say it also can reduce emissions. How does that work?
So emissions comes from having the engine run at the optimum conditions. With today's control, as I explained, you quite often have one actuator moving and it changes the sensor state for these other controllers. Each one of those has the ability to impact the engine out's emissions. So the OEMs, they have a big challenge. They have to calibrate this whole engine to sing and dance well together to meet the emissions requirements. Well, once you're able to do coordinated control of your actuators, you can now take and improve the overall emissions level of the engine because you're able to reduce things like rich and lean excursions in the air-fuel ratio of the engine, which directly impacts the engine's emissions output.
Rich and lean excursions, you lost me on that part.
So everything works by finding this optimum balance. And in an engine, whether it's a gasoline or a diesel engine, there's this ideal ratio between the air and the fuel coming in that you want the engine to be at for it to be running at its peak condition. Well, as you're controlling the air and you're controlling the fuel, all of the things that are influencing the amount of air going into the engine and the amount of fuel going into the engine will impact the ability for that engine to be at that optimum condition. With our control, you can also not only control the engine, but also in the diesel engine, you very often have an active exhaust system. So this means that there's actual control happening in the exhaust system of the engine, which ultimately will impact the emissions coming out the tailpipe. If we can coordinate all this together, as we do, you can now have the engine running in a more optimum state to give you, again, reduced engine out emissions, reduced fuel consumption, reduced warranty, and do this in a shorter period of time, which will allow you to further refine your design and not only improve the performance, but also reduce the cost of the system.
Which cars is this technology currently being used in?
Well, it's a brand new technology from the auto's perspective, so there's a lot of development work happening. There's more than 8 different OEMs that are starting to use this in early parts of their research, and we're hoping to see vehicles on the road before the end of the century.
End of the century. So
by 2018 or so, we expect the first vehicles to be sold using the technology.
What
decade, I guess.
What I was thinking that was a long time frame you had there. So what other industries has this these controls been used in before?
Sure. So the 22 of 25 largest oil refineries in the world are running this technology today. This technology is used throughout the paper manufacturing industry. This technology is used throughout the chemical manufacturing industry. And as we spoke about earlier, this technology is used in the aerospace industry for doing flight controls for a number of aircraft.
So, so you're trying to sell this technology to the car manufacturers? Is that who the end consumer is for you?
So we're working with the car manufacturers, we're working with the tier 1 suppliers, and we're also working with the engineering service suppliers. So the companies that today do a lot of the contract engineering and contract calibration for the OEMs, yes.
So you mentioned emissions, so that's a big topic in a lot of states, especially California. How does this, how will this help car manufacturers to meet increasing emission standards over time?
Sure. So as you're aware, for every vehicle that's sold, you have to have an EPA certification on the emissions, and if the vehicle is going to be sold in one of the 17 states that is part of the California Emissions Alliance, you have to have a CARB certification. So what this technology does is it allows you to have better engine out emissions, but it also allows you to improve the diagnostics of the vehicle. So the auto industry is required to have what's called OBD, onboard diagnostics, and they're required to determine when the vehicle has gone out of compliance. With this technology, you have the ability of improving your OBD monitors and reducing your CARB deficiencies, which ultimately are fines that an engine manufacturer has to pay when they sell their vehicles. In 2012, there was approximately $25 million paid to CARB for OBD deficiency fines. This technology can help the OEMs and is helping the OEMs to address and remove those deficiencies from their products.
So are they excited about this technology?
The value proposition to the OEMs is very large. We have one OEM that's calculated over a $300 million a year value that this technology will bring to their operation.
Can you tell us who that is?
At this point, no, but hopefully it'll become apparent as vehicles start to hit the road in future years.
Why should this matter to the end car buyer ultimately?
Well, as a car buyer, you're worried about a few things. You're worried about the cost of your vehicle, you're worried about the emissions or the fuel economy of your vehicle, and you're worried about the fun to drive of your vehicle. This technology allows the OEMs to get the vehicle performance to where you want it to be, get the fuel economy improved, and do it at a lower cost. So ultimately, you end up with a better vehicle than you have today.
You mentioned that this can help in the design phase of a car. Can you explain a little bit about how that would work?
Sure. So there's a lot of work that happens early in the development of an engine. And when what you're trying to do there is you're really trying to select the optimum hardware set to meet whatever set of goals that you've put forth for that powertrain or that vehicle. Today, that process can be very cumbersome because with each hardware set, you have to develop a controller and you have to run extensive testing to compare hardware set A to hardware set B to hardware set C. With our technology, you have the ability to take and have full control over very different hardware sets very quickly at no cost to the OEM in terms of having to develop a new control system, because the technology is extremely adaptable to allow you to make changes to what your control configuration is. So the OEM can select different sensor sets, they can select different actuator sets, they can select different components and be able to really find what is that optimum configuration from a performance, cost, and emissions perspective.
When do you expect this new startup within a big company, as you describe it, to start having an impact on the bottom line?
It's a very good point. I'm asked that question very often. We have a lot of customers working with the technology today. We have a lot of customers that have proven the value within their organizations. We look within the next 2 to 3 years to have this become a very profitable business for Honeywell.
And how long is Honeywell willing to stick with it sort of in startup phase before you start turning some real profits?
We've got support all the way up to our CEO, and they're very committed to the technology, and they see the value that this can bring to the industry.
Great. Well, thanks for taking the time to sit down.
Great. Thank you.